So we have a gentle introduction to chapter 8, looking at sequences. Linear, first difference is the same. Quadratic, second difference is the same. Cubic, third difference is the same. So fill in the empty boxes here. So let's look at A first. I'll just write the differences between 9 and 14 is 5. Then 14 and 21, 7. 21 and 39, and then 11. So the second difference is 2. So A is definitely quadratic. We have differences of 3 all the way along here. So B is linear. Cubic. Let's have a look at C. We'll just write the differences over here. C, we have between 5 and 7. We have 2 between 7 and 12. 5. Then we have 12 to 19. 7. 19 to 31. 12 and 31 to 50 is 19. Next difference is 3. 2. 5, 7. Doesn't look like it's any of these. Looks like C. And then cubic, we have the differences along here, jumping quite quickly. 3 to 22, we have 19. 22 to 59, it's going to be 37. 59 to 120 will be 61. And 120 to 211 will be 91. Next differences will be 19 to 37, 18. 24, 37 to 61, and 13. We can see here the third difference is 6. So cubic for D, cubic. Similar in question 2. In each case, identify whether it's linear, quadratic, cubic, or none, and write the next term. And then the final term, which you might not have seen before, Fibonacci, where we add 3 terms together. So 1, 1, and 2 is 4, gives us this term. Then you'd have 1, 2, and 4 is 7, which gives this term. We'll come to this in a minute. Here we have the first difference is 5, all the way along. So linear, next one will be 39. So linear, I'll just put L for linear, next term 39. For the second one, we have 6 to 12, I'll do them up here. 6, we have a difference of 6, we have a difference of 8, then we have a difference of 10, and then a difference of 12. And the second difference is 2. So we have quadratic, Q for quadratic. The next term would jump 14 to give us the same pattern along here. So 14 and 42 will be 56. Now we have 7, 19, 7, 19. 26 to 63 is going to be 37. And 63 to 124 is 61. So we have 12, we have 18, and we have 24. And then we have a difference of 6 for our third difference. This will be the first difference, second difference, third difference. So we need to work our way back up to get the next term. So after 24, the pattern will be, to keep a difference of 6 will be 30, and adding 30 onto 61, we get 91. So 91 for this one, for the next term, and it's cubic. Now 3, 10, 21, we have a difference of 7, 11, 15, and then 36 to 55 is 19. Then my next difference is 4, so this is quadratic. Quadratic, and then adding 4 onto 19 to get 23, and adding 23 onto 55 would give 78. 78. Then we have a decreasing sequence going down in 2s, 18, 16, 14. So just 8 is the next term here. We can see it's going to be linear. 8, and just adding the 3 terms together to get the next term. Obviously, just add these 3 terms together. So we're going to have 68, 24, 44, and 81 is 147. And this is T for Fibonacci. Question 2. Question 3 starts with draw the next term in the sequence. Well, we're just adding, we have 1 dot, then we're adding 2 dots, then we're adding 3 dots, Then we're adding 4, so I'll just put the next sequence here. We're adding 5 dots. 1, 2, 3, 4, and 5. So you've got a snooker triangle, 15 balls. A couple of questions to follow. We're asked to count the number of dots in each and write them as a sequence of numbers. So we've got 1, then we have 3, then we're adding 3, so we've got 6. We're adding 4 to get 10. We're adding 5, there's 15 in the last sequence. Is it linear? Well, let's have a look here. 1, 3, 6, 10, 15. Going up 2, 3, 4, 5. Second difference is the same. Second difference is 1. So it's quadratic. Quadratic. And then noting the nth term of the pattern will have 1 plus 2 plus 3 plus 4 plus n. Use the formula. Sn is equal to this formula that we're given in the formula booklet to find an expression for the number of dots in the nth pattern. So n over 2 on the outside. 2a will be 2 by the first term, 1, plus n minus 1 times the difference, which is also 1. So we get n over 2 times 2 plus n minus 1, which becomes n over 2 times n plus 1, which is equal to n squared over 2 plus n over 2. Doing it the way I probably taught you before, the second difference is 2a, so 2a is equal to 1. So a is equal to 1 over 2. And a, b, and c being an squared plus bn plus c for every quadratic. Term 0 is equal to c always. So if we go backwards and complete our pattern, this would be 1, and this will be the number 0. So c is equal to 0. And always a plus b plus c is equal to term 1, which is 1. So we have a as a half. So a half plus b is equal to 1. So b is equal to a half as well. So we fill this in, we get a half. I'll just do it over here, a bit of room. We get a half n squared plus b is a half too, so a half n, which is the same as this guy here, a half n squared plus a half n.